This is Professor Pelt, and this is Algebra 2, Chapter 7, Section 4, Adding and Subtracting Rational Expressions. So next thing we have to do is the complex fractions that are rational. Or, of course, rational is fractions, but so fractions within fractions. So in these cases, you're going to have multiple denominators. You need the LCD of all the denominators in this case and multiply by that on the top and the bottom. Okay. So if we look here, we have 6. Oh, my pen didn't turn on. We have 6, 3, 5, and 10. So 6 is 2 and 3. 3 is just 3. 5 is just 5 because they're both prime. And 10 is 2 and 5. So lowest common denominator. What do we have for commons? We have a 2 common. We have a 3 common. And we have a 5 common. They don't need to be common between all of them, just some of them. And there's nothing left over in this case. So that's what 6 times 5 is 30. So we multiply by 30 on the top and 30 on the bottom. You can put an over 1 if you want to. Okay. But 1 times the denominators isn't really going to change anything. Okay, there's a couple ways to do this. We just multiply straight across. So we have 30x over 6 minus 30x over 3 over 30x over 5 minus 210 over 10. Because again, you're multiplying 30 over 1 into both terms of the binomial. So simplified, I get 5x minus 10x over 6x minus 21. So the numerator can be combined because they're like terms. The denominator is not. So it's negative 5x over 6x minus 21, where x cannot equal, well, I have 6x over 21 here, right? So 6x minus 21 cannot be 0. So 6x cannot be 21. So if I divide by 6, x cannot be 21 over 6. Okay. All right, let's try example problem B. All right, so sometimes you might have a mix of fractions and non-fractions, but you can make them all fractions. So I can rewrite this problem as 1 over 1 plus 1 over x, 1 over 1 minus 1 over x. So the LCD in this case is 1x because they have an x in common and a 1 in common. That's it. Okay. So I'll multiply the top by 1x and the bottom by 1x. You can put it over 1 if you want to. It's not entirely necessary because if you multiply 1 through the denominators, it doesn't change them. So that gives me x, 1x over 1 plus 1x over x over 1x over 1 minus 1x over x. Okay, so simplified, I get x plus 1 because those cancel. On the bottom, I get x minus 1 because those ones cancel. So that is my simplified expression. However, where x cannot equal 1, because if I plug in 1 here, I'm going to get 0 on the denominator. Also, looking back at the original problem, I cannot plug in 0 into those monomial terms. So that is another term that I cannot, or another value of x that's limited in the domain. Okay, let's go to C problem for the examples. Okay, so the LCD here, they have in common an x plus 4. What's left over is an x when you look at all three of the fractions. So I'm going to multiply by the LCD on top, which is x and x plus 4, and multiply by the LCD on the bottom, which is x and x plus 4. And again, you can put it over 1 if you'd like. It won't really make a difference because 1 times anything is itself. So I get on the top 5x, x plus 4, over x plus 4. On the bottom, I get x, 1x, x plus 4 over x plus 4 plus 2 times x plus 4 all over 1, right? Because again, it has to go to both terms on the bottom and the one term on top. So cancel, 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 cancel. So I'm left with just the 5x on top. On the bottom, I'm left with 1x plus 2x times the x plus 4. Let's write this a little bit better here. Okay, let's try this a little bit better. Okay, so that is x plus 4. That's a little bit neater. Okay. Oh, you know, we lost an x actually. There's an x right there, right? There's an x traces right there. So those x's would cancel. That actually was a 2. I was right the first time. Okay, so if we keep going, that's 5x, and that's x plus 2x plus 4. So that gives us 5x over 3x. Ah, that's not 4. That is 8, right? 2 times 4 is 8. Okay, let's see. So I think we're good there. Where x cannot equal, well, 3x plus 8 cannot be 0, so 3x cannot equal negative 8. So x cannot equal 8/3. Also, if you look back at the original problem, x can't be negative 4 and x can't be 0. Okay. All right, pause the video. Try the student problems for yourself on the next page. Okay, so next example, we have all monomials, the lowest common denominator. What do they have in common? Just an x. What's left over? That's a little tricky here because we have x, we have x, we have 2, and we have 4. And the 4 is 2 and 2. So we already took the common x, but we also have a common 2 and 1, 2 left over. So the lowest common denominator is 4x. Okay, so we're going to multiply both the numerator and the denominator by 4x. Again, you can put the placeholder as 1 if you want to, but makes no difference. So that gives me 4x over x minus 12x over 2 when I distribute. On the bottom, when I distribute, I get 4x over x plus 12x over 4. So I can simplify and get 4 minus 6x over 4 plus 3x. That's as far as we can go with the simplification there, where x cannot be equal to, well, if you go back to the original problem, you just couldn't plug in 0. And in this part here, 4 plus 3x cannot be 0. So 3x cannot be negative 4. Thus, you cannot be negative 4/3. Okay. All right, let's go to student problem B. All right, so you can rewrite this problem because some of these don't have denominators. So you can make denominators, which is a 1 as a placeholder value. I kind of combined that subtraction there. Let's fix that a little bit. Okay, so lowest common denominator. They have an x in common and a 1 in common. So that's it. It's 1x. So multiply by 1x on the top and 1x on the bottom. So if I do that, I'm left with 2x over x minus 4x over 1. On the bottom, I get 2x over x plus 3x over 1. So this leaves me with 2 minus 4x over 2 plus 3x when the x's cancel. So that is our simplified term because I can't factor anymore, where x cannot be 0 because the original problem, and if 2x plus, I'm sorry, that's 2 plus 3x plus 3x can't be 0, 3x cannot be negative 2, or x cannot be negative 2/3. Okay. All right, let's go on to student problem C. All right, so now we have just polynomial denominators here, so lowest common denominator. They have an x plus 5 in common, and what's left over is an x minus 3. So it is a polynomial to binomial lowest common denominator. So multiply on the top by x plus 5 over x minus 3, and on the bottom x plus 5 over x minus 3. And again, you can put the placeholder 1 in there if you'd like. So on the top, we get 3 times x plus 5, x minus 3, all over 1 times x plus 5. That's x plus 5. Okay, and on the bottom, we have 2 times x plus 5, x minus 3, all over x minus 3, plus, right, so we have 2 terms here on the denominator, 1 times x plus 5, x minus 3, over 1 times x plus 5. Okay, so we distribute this to both fractions. Okay, so in the numerator, the x plus 5's cancel, leaving us with 3 times x minus 3. On the bottom, denominator, x minus 3's cancel, so left with 2 times x plus 5. And the x plus 5's cancel again, which leaves us with plus 1 times x minus 3, which don't cancel because it's a plus, not a multiply, right? So if we do out the math now, we will get, let me think here, 3x minus 9 over 2x plus 10 plus 1x minus 3, which is 3x minus 9 over, let's see, 3x for the 1x and 10 minus 3 gives me 7, which don't cancel each other, so that's the final term, where x cannot equal, so go back to the original. In the original, x can't be negative 5 or positive 3. Okay, and in the final one, 3x plus 7 cannot be 0, so 3x cannot be negative 7, or x cannot be negative 7/3. Okay, that is the end of part 3.